Hi everyone, thanks so much for coming. My name is Rahul Pathak. I'm the General Manager for Amazon Athena and for Amazon EMR. And what I'd like to do today is to just give you an overview of Athena, walk through some of its key features, talk a little bit about how some customers are using it, and I'm going to try and finish up in time to take a few questions. And again, thank you so much for your interest and for being here. Very excited to launch the service at reInvent, and we're already seeing quite a bit of usage, so this is great. Why did we build Athena? So we were talking to customers, and they found that they had to do some work, really, to get to their data in S3. And sometimes that work involved complex transformations, loading it into another system, or spinning up an EMR cluster. And while those are relatively straightforward, they still take effort. And you typically do need some special skills to manage a Hadoop cluster or a data warehouse. And so we wanted to make this a little easier. And, quick show of hands, who has data in S3 here? Okay, sounds about right. And who has familiarity with SQL? All right, so we're in the right place and we built the right product for you, I think. So we wanted to make this easier. And so, the point of view we took was we wanted to provide a query service that would let you query data in S3 without having to move it, query it in place, and you could use standard SQL. So the reason I've highlighted interactive query service is that we want to get you results fast, so most results come back in seconds. And it's also not a database. So this is for querying data in S3. It's not designed to be a database. It's not designed to be a data warehouse. It's designed to allow you to write fast SQL queries with nothing to manage. And so Athena's serverless. Essentially, we are taking care of all of the aspects of running queries for you, so there's nothing for you to manage or to pay attention to. We maintain warm pools of compute capacity, so when you log in and run a query, you get a response right away. There's no waiting for anything to provision. And because we're delivering it as an automated managed service, when we make updates to the service, those are completely transparent. You will not notice them. You'll just see new capabilities and features come into play. And what we wanted to do was to make this super simple to use. So the idea is that you log into a console, you're presented with something that looks a lot like a SQL editor, and I'll show you some screenshots in a second. Once you do that, you have to define a table. We chose to use Hive syntax for our DDL statements, our data description language. And this is really because Hive is very flexible. It allows you to query and define tables in a variety of data formats. And these are open formats, so a lot of our customers are using technologies like EMR already, and we wanted to make it easy to slot Athena into their existing systems. And the console also has an add table wizard, which will walk you through the process of pointing to data in S3, setting up a table, and then once your table is set up, you're essentially writing SQL queries as you would against a normal database. One other thing to keep in mind is that all tables in Athena are defined as external tables. And what this means is that when you take a table out of the Athena catalog, it doesn't do anything to your data on S3. We don't do any modification. It's a read-only service from an S3 perspective. It's highly available. So we're running warm compute pools in multiple availability zones. You connect to the Athena endpoint or log into the Athena console. And so if there's any issue, we'll automatically route queries to an area where we do have access to capacity. Similarly, your data is stored in S3. S3 is highly available, and that's 11 nines, by the way. That's our design point from a durability perspective, so your data in S3 is replicated automatically for you. So what this means is the compute is highly available and the data is highly available, so you have a service that will be there when you need to run a query. And this is true for the console. It's also true when you access Athena through a SQL client like a JDBC Driver-enabled client, and I'll talk about that as well. But our goal was that your data is there and you can run queries when you want to. You shouldn't be affected by anything that's going on. And then another important consideration for us was querying data directly from S3. So we didn't want you to have to move your data at all. We wanted you to be able to query it in your raw format. And we support a range of formats: text, CSV, JSON, web logs. We have customers querying ELB logs, CloudWatch logs. So really every log that a service generates can sit in S3. You can define a schema on it using Hive and begin running SQL queries against it. And if you convert your data to an optimized form, so that's ORC and PARQUET, these are open source data formats that are columnar and that they support compression, so this gets you better performance. It also lowers your query cost, and I'll talk about the pricing model for Athena in just a second. So what this means from our customer's perspective is there's no data transformation needed. There's nothing ever stored anywhere in a cluster. You're streaming data directly from S3. And this allows you to have S3 as your primary data store backing everything, so you get durability and availability for free. There's also no concept of loading data into Athena, so when you're not using Athena, there's no additional charge. You're just paying for the data that's sitting in S3. It's ANSI SQL, so we use Presto as our query execution engine. I'll talk a bit about that in a second, but this is an example. It's unreadable, but it's just designed to show you that it's a complex query. It's actually one of the TPCH queries, but it's got aliasing, it's got multiple joins, it's got subqueries. You can really write pretty complex ANSI SQL. And then with Presto, there's also support for window functions. It's got JSON functions, approximation queries, so really a very powerful query engine. And then we also support data partitioning in Athena. So if you have partition tables, the idea with a partition table is, think of a system with log data coming in every day. You might have a partition per day that gets added as your data evolves. And so Athena supports partition data out of the box, which means that when you're running queries against partitions, it can go to the right partition rather than having to read everything. So this is a way to simplify your data operations and actually get better performance. And because you'll be scanning less data, you'll pay less. And then Athena supports full Hive partitioning, so you can pick any column or set of columns to do that. We're using familiar open technologies under the covers, so we use Presto. Presto is an in-memory distributed SQL engine that was developed by Facebook. It's open source. We contribute to it, and it's been proven out at Facebook scale, so hundreds of petabytes, and that's part of the reason that we chose it. It's fast and it's very scalable. And then we use Hive for defining tables. This is just a standard in the big data world, and it gives you a lot of flexibility. You can actually use a regex to define a table on top of data, so tons of flexibility in defining your schemas. And Athena and Hive generally use a concept called schema on read, so the schema is actually just metadata, and when you run the query, it's projected onto the query, so you don't have to move your data around at all. And different people can have different ways of defining tables on the same data set, and they can all run their own queries as they see fit. So it's a very powerful, flexible system that gives you a SQL interface without any need to move data around. And then because we're using Hive, we get access to a ton of the formats and flexibility that are supported. I think we've talked about text files, CSVs, arbitrary log files, arbitrary delimiters. You can use simple and nested JSON directly. We support compressed data, so whether that's gzip or snappy, you can essentially have your data compressed, and we recommend that, and I'll talk about why compression is good. It's really for performance. If you need to read less data to answer a query, that query will complete faster, and it's also for cost. We charge you based on the amount of data we scan, so the less data we scan, the less you'll pay for that query. And the columnar formats are what we recommend for use with Athena, because when you have a columnar format, each column in your table is stored independently. So if you only query a subset of the columns, we only read the columns that are relevant. And so you end up saving and getting better performance. So compress, use columnar formats. It'll improve performance, reduce cost. And then I've already gotten probably several dozen questions about Avro. We're getting support for Avro, which is a format that carries the schema definition along with the data, and that'll be coming pretty soon, so just stay tuned. We hear you, those of you who've asked me for Avro. So we've also designed Athena to be fast. This was important to us. We wanted it to be interactive. We wanted you to be able to type in a query and get back results right away. And so we automatically parallelize queries across multiple cores. We stream results to the console. We also write results to S3, so you can specify a result bucket. So what this means is that you can run queries on data. Maybe you're querying raw JSON. You'll then get a CSV written out to S3, and that can be used in a subsequent step or pipeline. And to improve performance, compress, use columnar stores. I'll probably talk about this a few times, but I'll show you at the end the gains can be pretty dramatic. You can see 10x savings in performance and cost by using formats like ORC and PARQUET. So from a cost perspective, we wanted to make Athena extremely cost effective. When you're not using it, there's no charge. There's no hourly charge or anything like that. You're only charged when you run a query. We charge $5 per terabyte scanned from S3. And we also don't charge you for DDL queries if you're defining tables. If queries fail, you're not charged for those. And when you compress data, because we charge based on the volume scanned, if you think about it, if you have a terabyte table and you have to scan the entire table, that's a terabyte. If you compress that table and it takes up, and you get 5-to-1 compression, you're not going to scan a terabyte, you'll scan 200 gigabytes. You'll pay 1/5 of the cost for that same query just by compressing your data. And then column formats get you even more efficiency. If you imagine a table with 5 columns, you compressed it, so you get a factor of 5 savings there. If you only read 1 column in your query because that's all you cared about, you wanted to sum the sales, for example, over the past month, you'd read 1/5 of the data, so that query would actually be 10 times, 1/5 of 1/5, so 1/25 of the initial cost. And that's dramatic savings from that perspective. So if you do some work on compression, you'll get dramatic savings on the back end. So let's talk about how this might be put into use. So imagine data sources. This could be mobile devices. This could be web application servers. They're generating log files. Those log files can go onto S3. You might use EMR to transform those log files into a form that's ready for ingest into Redshift, which is our data warehouse service. Redshift's favorite data formats for ingestion are compressed CSVs. So you might see your JSON being transformed into that form and then being brought into Redshift. And then you might do some visualization using QuickSight, which is our visualization, web-based visualization if you're not familiar with it. So how would you plug Athena into this? There's a couple of places. You could have ad hoc SQL access to your raw data. Again, there's no charge when you're not using it, so you would just define tables. And then you can query that data whenever you want, the instant it came in. You can also choose to use Athena on your compressed CSVs when they're going into Redshift. So maybe you've done some deduping, some sessionization, and you've got that data ready to go. You can query it directly there. And then we integrate with QuickSight as well, so you can use QuickSight to visualize data in S3 through Athena as the query engine underneath. So that gives you access to things like JSON, PARQUET files, all of that. So we wanted to make it as simple as possible to slot this into your existing data flows. So when we talk about some of the challenges that customers were facing, we really wanted to make sure we addressed all of them. So we want people to be able to query without doing any data loading or data transformation. We wanted people to not just have access to aggregated data sets, but also to their raw data. And so Athena allows you to do that. And we took away all of the infrastructure to manage it on your behalf. So essentially what you get is you log in, and you run a query, and you get results. So let's talk about what the workflow is to actually use Athena. Has anyone used it yet? Tried it yet? A few people? Okay. So essentially, when you log into the console, what you get is a very simple, clean SQL client. So you've got a query editor. It has keyboard binding, so you can hit Control-Enter and run your query. It's got a result window beneath it. And then your database and tables are on the left-hand side. So a simple 3-pane system. If anyone's used desktop SQL clients, it'll feel very familiar. The query editor has autocomplete. It also has SQL formatting, so you can just paste in SQL, format it. You can use autocomplete for table and columns. And the catalog itself is where you store your table definitions and metadata. So you create a concept called a database. This is just a collection of metadata. And then you create a table definition underneath that, and that contains the column structure of your table. And you can click into it, and you can see all of the columns that go into the table beneath that. So again, a very familiar interface from a data catalog and data browsing perspective. And if you click in, you can start to, there's a data catalog manager, so you could start to see details about your columns, how they're defined. And if you click further, you can see more detail about where the files backing that table definition actually live. So in this case, you can see that these are CloudFront logs. You can see the location is on S3. And essentially, the table metadata is just a schema that's projected onto that S3 object unmodified at query time. And then when you run a query, you just run it in the SQL editor. You'll get back results streamed to the console. Those results are also written to a results bucket on S3. And that's where you can go if you want to actually use the output of those results. We also have a download to desktop capability. So if you want the results as a CSV on your laptop, you can do that as well. And we also ship with a free JDBC driver out of the box, so you can connect it to your SQL client. I think these are screenshots of SQL Workbench, which is a free client. And essentially, you'd be downloading the driver, configuring your client to use it, and then this allows you to then run SQL queries against Athena from a laptop or any device that you have. And even though you're using a familiar SQL client, you're actually connecting to the Athena service, so you're not connecting to an actual physical database of some sort. So you get all of the benefits of high availability, all your data's there. You get all of the power of Athena just connected to it directly from a laptop or other system. And then we wanted to make Athena straightforward to use with QuickSight. So QuickSight is our visualization service at AWS. So this makes it easy to visualize data in AWS data sources. And QuickSight can auto-discover your data sources in AWS, and then it allows you to pick them, bring them into QuickSight, and then interact with them visually. And so when you log into QuickSight, you get a very straightforward interface with the ability to pick your AWS data sources. QuickSight can bring in data directly from S3 or RDS or Redshift. Athena is also available. And so if you click that, you essentially define a name for your Athena data source. And then you can go into it and pick the tables that you want QuickSight to have access to. And once that's done, you can, there's a concept in QuickSight called Spice. This is an in-memory layer that you can stage your data in that for super fast access to it. But you can also use Athena in a direct query mode and run queries directly against data in S3, perhaps accessing data sets that might be too big to bring into Spice, for example. And then once you're done with that, you have visual access to all of your data in S3, again, with nothing to manage. So it's a very powerful way to get access. This is a flights database, and you can quickly design dashboards, drag and drop, and essentially what you're doing each time you modify is you're interacting with your data in S3 via Athena. So anything that you can query with Athena, you can visualize in QuickSight. And then with JDBC drivers, we've also designed these. If you want to run automation, you want to design programmatic systems, this is just sample Java code in our documentation. This allows you to set up automation so you can build systems. For example, there might be a scenario where you've got data that arrives in S3. You might want to generate a Lambda event when that data arrives. And that Lambda event could use the JDBC driver to update Athena's catalog to say that there's a new partition. And so that data is then available to be queried by whoever's using Athena. And this is sample Java code. We also have the ability for you to provide your own signer class. So you don't have to use your AWS secret key and credentials. You can actually just use something to deliver a signed request using IAM. So those of you that are experienced with automation on AWS, that capability is also there for you to use. But this is, as you can see, it's a very standard JDBC setup. Username, password, you define the output location for your query results, and then you can start and create a JDBC connection. And so this is just an example. If you're creating a table, you can see that you're basically setting up a statement. You're defining then a call to Athena and passing it the SQL. And it's going to create a table. It's got the S3 location there. And once you do this, this table will then show up in the Athena catalog if you were to refresh the console or look at it on your database side. And then executing a query, same sort of thing. So you can build applications that programmatically have access to Athena using this system. So let's talk about creating tables and how this process works. So we use Hive DDL. Just folks familiar with Hive in the room? Okay, handful. That's pretty good. So Hive, it's an Apache project. It was one of the original analytic systems there, and its Hive statements can be submitted directly to Athena, so you can punch them into the query window. So if you have existing Hive-based DDL infrastructure, which you likely do if you're using any of the big data stack, that all of those DDL statements can just be pasted in. It looks a lot like SQL, and it's schema on read. So this is that concept of projecting schema at query runtime and completely independently of the underlying data format. And the external concept in Hive, external tables are considered unmanaged by the system. What that means is when you delete external tables from Athena, it has no impact on your data in S3. And so this is because we wanted to focus on providing a read-only query service, not anything that would modify your data in S3. So we only support external tables in Athena, and that's by design. We don't want you to be able to modify anything from this system. It's really designed for query. Big range of data formats. SERDE is a concept in Hive. It stands for serializer and deserializer. We ship with a range of these. Essentially, this is code that allows the system using the table to understand how to read and write from that underlying data source. And so we have serializers and deserializers for things like JSON. As I mentioned, we'll be adding it for Avro. So your data always lives in S3. And then the metadata, which is the table definition, that's stored in Athena's internal catalog. That also is highly available and scalable. So the internal metadata store, this is our internal catalog. This is what you see on the left pane of the console when you log in. And all your table definitions are stored here. So tables, columns, partition data. This is a highly available auto-scaling system. So every element of the service is highly available. There's nothing for you to manage. You just enter your tables. You can click on the eye icon to see, get the table effectively just listed in the console. And you can click on the properties to see more details on that table, like when it was updated, where it's stored on S3, etc. And it's Hive Metastore compatible. So if anyone's using Hive Metastores, essentially everything that you do in that world you can do in the Athena catalog from a DDL perspective. So when you're running queries, it's straightforward. This just shows the console query window expanded to cover the full console. It hides the table structure. You paste in or type in SQL. You can then hit run. It'll run the query. You'll get back results. What we show you in the console and in the history is the query runtime, how long it took to execute. We also show you the amount of data scanned. And the data scanned is really all we had to read from S3 to respond to generate the query results. And that's the unit of billing for Athena. There's no charge for anything else. And when we run queries, we automatically save the results to S3. And in the query history part of Athena, which I guess I'll show you in a second, there's a history of all the queries that have been run. And if you click on the results that show next to that, we show you the historical results from S3 of that query execution. And then when we talk about columnar formats, I'm spending time on this just because I think it's important because it can help you with performance as well as manage costs. So PARQUET and ORC are columnar formats. They're open source. They're part of the Apache ecosystem. And with PARQUET, this is a columnar format, so data is stored in columns. If you have a table with 5 columns, it'll actually generate 5 files underneath it, and each column is stored separately. And the schema follows along with the data itself. And it's got built-in compression, and it's got built-in information about what's in the actual columns. So if you're doing things like counts, it doesn't have to read all of the data. It stores that information, stores min-max values. And so what this means is when you're running queries, it can optimize and decide not to read things in order to respond to those queries if that metadata is available to it. And then predicate pushdown means that if you have filters on your data, so you're looking for a date range perhaps, it can actually use that to eliminate things to scan. So again, we're trying to be as efficient as possible and read as little as possible in order to return the results of the query. And the less we read, the less that query costs, and that's why we've spent a bunch of time trying to make sure that we can use data from S3 efficiently. Similarly, ORC is just another choice of format that you can pick. And this is also a top-level project in Apache, similar idea, built-in compression, it's a column format, and it also supports predicate pushdown. So it's really just a choice. If you standardize or one or the other, you can use that. Essentially, as with all things related to databases, you want to be testing to see which formats will give you the best performance with your data. But that's all supported natively. And if you're converting data, so you might have JSON and you want to convert it into one of these optimized formats like ORC and PARQUET, Hive has a create table statement, so that CTAS stands for create table as select. So essentially you're querying one table and then you're writing it into a form. And with Hive, you can pick how to store that data. So in this case, it's stored as PARQUET. And you can run a select query, and the output of that query will be written into S3 in a PARQUET form. You can also use things like Spark on EMR to convert that data. We've published some very simple code on GitHub. It's completely open source that shows how you can convert files into Parquet and ORC. And it's about 20 lines of Python, and this can convert a terabyte of text into 130 gigs of data on Parquet, and using a compression technique called Snappy. And the cost for this is $5. So you can do, it's a low-cost, scalable way. And if you already have existing big data workflows, choosing to convert to Parquet is pretty straightforward. So diving into cost a little bit. So what we do with Athena is we want you to only pay for when you're using the service to run queries. So that means you could provide Athena to everyone in the organization, but only when they run a query do you actually pay anything for it. We charge based on the amount of data scanned. So it's $5 per terabyte scanned. And you can save money by compression, using column stores, using partitions. And the way you save is that every one of these steps means that we read less data. And again, there aren't any charges for DDL queries or for failed queries. If you do cancel a query, we will create a charge for the amount of data scanned up to that point. So that's one thing to just keep in mind. And I just wanted to show you in this example what we're doing here. So the query in the top right is a pretty simple select and aggregate. It's going to about 4 columns. The actual table that this is on, I think these are ELB log files, Elastic Load Balancer logs. There's about 30 or so columns in the table. So if you had the data stored as text files, they take up about a terabyte uncompressed. Running that query on this data, in this example, took 200 odd seconds. And it scanned 1.15 terabytes. So at $5 a terabyte, the cost for that query is $5.75. If you converted that data into Parquet, columnar, and compressed, it takes up about 130 gigabytes on S3. So you're saving on your S3 costs. The query runtime for this query, scanning only 4 of the columns, 5.13 seconds. So dramatically faster, almost 34 times faster. And then it's scanning much less data. Instead of 1.15 terabytes, instead of 1,000 plus gigabytes, it's scanning only 2.7 gigabytes. So it's about 99% less data is being scanned. And so you've got a query that costs the same query on the same data, getting back the same results. If it's uncompressed text, you're paying $5 and change. If you're running against Parquet, it's costing you 1.3 cents. So please, compress your data, use columnar formats for data you query often. So I want to talk to you about a few customer use cases. I also want to explain a little bit how we think about Athena fitting into our ecosystem at AWS. So QuickSight is our visualization service. It can query data from any of these systems. It can also load data directly from S3. And that gives you interactive visual queryability for your data. So you can play with dashboards. You can share dashboards with others in your company. And that makes it just very easy to consume. Redshift is our petabyte scale data warehousing service. So if you're, it essentially allows you to store 2 petabytes of compressed data in a single cluster. And Redshift is our highest performant SQL engine. So if you're running very complex queries on structured data sets, you'll get the best performance out of Redshift, and it's great for large-scale data warehousing. EMR is our Hadoop and Spark service. And that also interacts directly with S3, and it also supports a broad range of open source projects. I think there's 16 out of the box, and you can run whatever you want. And this is great for scenarios where you're not just doing SQL. You could be doing machine learning. You might be using Spark to do some of that. And so EMR gives you that capability. And then Athena sits alongside this and gives you access to your data in S3. And it's as a query service. So when you just want to run ad hoc queries, and you don't want to take the time to load or manage this data into other systems, Athena's for you, so it fits in there. So these are some customers that have been using Athena in the private beta. So Live Intent is targeted email marketing. They look at events, clicks, how people are interacting with those systems. JW Player is a video player and video advertising analytics. We'll talk about DataZoo in just a second. They're a real-time ad bidding platform. And then you have Gnosi, which is a curated news application provider in Japan. News Corp is a diversified media conglomerate. Japan Taxi uses this. NASDAQ, I'm sure you're all familiar with. And then Inrix's use case is pretty interesting. They provide real-time traffic information, and they actually have logs about their traffic tiles and map tiles sitting in S3, and they use Athena to query that. So here's an example of DataZoo. So DataZoo is a real-time ad bidding platform. So if you're not familiar with this, what this allows you to do is essentially every time you look at a display ad on a web page online, as that page loads, dozens of companies are essentially bidding for the right to show you the ad that goes on that page. And that ad and bid and serving has to happen inside of 100 milliseconds end to end. And so DataZoo does about 3 million of these bid requests per second. They generate about 3 petabytes of raw log data per day. This compresses down to 180 terabytes of log data in S3 per day. And so this comes in through Kinesis, which is our real-time streaming ingestion layer. And to give you some context, if you wanted to capture all of Twitter in Kinesis, so 500 million tweets a day, it would cost you about 76 cents an hour. It's a very low-cost, high-scale system. They then transform that log data and load it onto S3, and they have custom visualization that they've built. They're now querying that data directly with Amazon Athena, and they also use Redshift to provide operational reporting on this. So it's exciting to see Athena being used at high scale in this way, but it also can be used really for very simple use cases as well, designed to go against data of any size. But I think one of my favorite things is this tweet came through yesterday. I don't think Andy's keynote had finished yet, and this person was already up and running, analyzing their performance logs using Athena on S3. And as the GM for the service, it's really gratifying to see a customer able to take advantage of it within an hour of it being out. And so thank you very much. We're a little early. We've got time for questions if there are any, but thanks very much for your attention.